In 1908, above a remote forest in Siberia, something exploded so violently that trees fell for miles in every direction. But when investigators finally reached the site, there was no crater waiting for them, no obvious impact hole, no great stone sitting in the earth, only a silent forest bent outward from a point in the sky. The event is now known as Tunguska, and more than a century later, it still feels like one of the strangest warnings the planet has ever given us. Not because scientists have no explanation. The strongest explanation is actually clear. Something from space entered the atmosphere and exploded before it reached the ground. But the details still matter, because Tunguska was not filmed. It was not photographed as it happened. It occurred in one of the most remote regions on Earth, long before satellites, dashcams, smartphones, or modern asteroid tracking. What remained was a pattern of damage, a handful of witness accounts, scattered measurements from far away, and a question that still carries weight. How can something flatten a forest and leave no crater behind? On the morning of June 30th, 1908, people living near the Podkamennaya Tunguska River saw the sky change. Some accounts describe a fireball moving across the sky, trailing smoke. Then came a flash. Then a sound like thunder. The blast was strong enough to knock people down. Some dwellings were damaged or destroyed. Reindeer were reported killed. Far from the center, instruments registered tremors from the shock. The most important witnesses were the Evenki people and other local residents who lived close enough to feel the force, but far enough to survive. To them, it was not an abstract scientific event. It was heat, light, wind, and sound. It was the sky turning dangerous. Then, for years, the forest kept its secret. The region was difficult to reach. Russia entered war, revolution, and civil conflict. Scientific expeditions were delayed. The first serious attempts to understand the site came long after the morning itself had passed into memory. Leonid Kulik, a Soviet mineralogist, became one of the central figures in the search. He first tried to reach the area in the early 1920s, but the landscape was too remote. In 1927, 19 years after the explosion, he finally arrived. What he found was not a crater. It was a forest shaped by force. Trees had been knocked down across a huge area. In many places, their trunks pointed outward, away from a central zone, as if a giant hand had pressed down from above. Near the center, some trees still stood upright, but stripped of branches and bark. They looked less like trees than poles left behind after a wave of heat and pressure had passed through them. That detail mattered. If a large object had struck the ground, investigators expected a hole. But if the object had exploded above the ground, the center would look different. The shock wave would come downward and outward. Trees directly below the burst might remain standing, while trees farther away would be pushed flat. That is the picture Tunguska slowly began to reveal. A blast in the sky. Not an ordinary impact, an airburst. Today, the most widely accepted explanation is that a cosmic body entered Earth's atmosphere at tremendous speed, heated under atmospheric pressure, broke apart, and released its energy before reaching the surface. NASA's more recent modeling points toward a stony object, perhaps somewhere around 164 to 262 feet across, entering the atmosphere at roughly 34,000 miles per hour. At that speed, the atmosphere is not empty space. It becomes a wall. Pressure builds faster than the object can survive. Heat rises. The body fragments. Energy that had been carried as motion turns into a sudden explosion in the air. The result can look, from the ground, like the world has been struck, but geologically there may be no crater at all. That is the quiet trick of Tunguska. The absence of a crater is not the absence of an impact event. It is a clue to where the energy was released, above the ground, in the atmosphere. Still, the details have never been perfectly clean. For decades, researchers debated whether the object was an asteroid or a comet. A comet-like body, rich in ice and volatile material, might help explain strange atmospheric effects reported after the event, including unusually bright night skies in parts of Siberia and Europe. But many scientists now favor an asteroid-like body, especially a stony one, because that better matches modern modeling of the damage pattern. Even then, there is uncertainty. The object itself was not recovered as one large piece. Later expeditions found small particles that may suggest extraterrestrial material, but tying tiny fragments conclusively to one morning in 1908 is difficult. The forest tells a story. The instruments tell a story. The witnesses tell a story. But none of them gives us the complete object in our hands. That is why Tunguska still feels unresolved, even when the airburst explanation is strong. It sits in the gap between explanation and recovery, between what the physics says likely happened and what the ground refused to preserve. For most of the 20th century, Tunguska stood almost alone in the modern imagination. Then, in 2013, another Russian sky lit up. Over Chelyabinsk, a smaller asteroid exploded in the atmosphere. This time, there were cameras everywhere. Dashcams, phones, windows, security recordings. The event injured more than 1,000 people, mostly because the shockwave shattered glass across a wide area. Chelyabinsk did not flatten a forest. It was much smaller than Tunguska. But it gave scientists something Tunguska never could. A modern, recorded airburst from multiple angles, with damage that could be mapped and compared to models. That changed the way researchers look back at 1908. If Chelyabinsk was the smaller warning, Tunguska was the larger shadow. By using modern computer models, researchers could test millions of possible combinations: object size, speed, angle, strength, altitude, and composition. They could ask which combinations produced a flattened forest without a crater. The answer did not point to fantasy. It pointed to a natural object from space, breaking apart in the atmosphere with city-scale force. That may sound less mysterious at first, but in some ways it is more unsettling, because Tunguska does not need a secret weapon or a hidden civilization to be astonishing. It only needs physics, a rock in the wrong place, the right angle, a remote forest instead of a city, and a planet that is usually protected by its atmosphere, but not always gently. One reason Tunguska matters today is that it changed from a mystery of the past into a planning problem for the future. NASA and other organizations now search for near-Earth objects, refine impact probabilities, and study how different bodies break apart in the atmosphere. Missions like DART have even tested whether humanity can alter the path of a small asteroid. That does not mean we should live in fear. NASA's more recent work suggests Tunguska-scale impacts may be less frequent than earlier estimates implied, perhaps on the order of millennia rather than centuries. But rare is not the same as impossible. The forest at Tunguska is a reminder that Earth's atmosphere is both shield and stage. Most small objects burn harmlessly. We see them as meteors, brief scratches of light across the night. Some are larger, some survive longer, and a few release their energy low enough to matter. When people ask why Tunguska still captures the imagination, the answer is not only the missing crater, it is the scale of the near miss. The same event over a different place would have become a human catastrophe, not just a scientific puzzle. Instead, it happened over a remote region of forest, where the damage could be measured in trees, distance, heat, and silence. Millions of trunks became the record. A landscape became the instrument. And the absence of a crater became the clue. Tunguska teaches a strange kind of humility. Not every mystery is a doorway to the impossible. Sometimes the most powerful mysteries are the ones that show us how much the ordinary universe can do. An object crossed the sky. The atmosphere resisted it. For a few seconds, motion became light, heat, pressure, and sound. Then the object was gone, and below it, the forest lay pointing outward from a place where nothing had touched the ground. That is what makes Tunguska endure. It is not simply an explosion. It is a missing crater, a flattened forest, and a warning written in trees.